Hi students, welcome back. Now we are going to discuss some problems in increasing and decreasing. Question number 1. Show that the function f of x is equal to 2x plus 3 is strictly increasing in capital R. Solution: we have to show that the function is increasing. For that, the given function is f of x is equal to 2x plus 3. Let us take 2 points at x1, x2, element of capital R. It is domain of the function. Now, to start like this, x1 is less than x2. That implies if multiply by 2, then we get 2x1 less than 2x2. Then we add 3 on both sides. We get 2x1 plus 3 is less than 2x2 plus 3, which is f of x1 is less than f of x2. Thus, we get x1 less than x2 implies f of x1 less than f of x2. That means f of x is a strictly increasing function on capital R. The next problem is question number 2. Show that the function f of x is equal to minus 3x plus 4 is strictly decreasing in capital R. The same way, the given function is f of x is equal to negative 3x plus 4. Let x1, x2 be any 2 points in its domain. Now we start with x1 is less than x2. That implies now we are going to multiply by minus 3. Then we get minus 3x1 is greater than minus 3x2. If we multiply by a negative number, then the sign of inequality will be reversed. So less than become greater than. That implies the next step is we have to add 4 on both sides. We get minus 3x2 plus 4. That implies f of x1 is greater than f of x2. Thus, x1x less than x2 implies we get f of x1 is greater than f of x2. That means f of x is a strictly, according to our definition, it is strictly decreasing in its domain capital R. The next problem is show that the function f of x is equal to a power x, where a is greater than 1 and x is an element of capital R, is strictly increasing in its domain in capital R. Solution: given function is given f of x is equal to a raised to x, a is greater than 1, x is an element of capital R. Now let us take 2 elements in its domain, this element of capital R. Now we start with x1 less than x2. ഇവിടെ ഒന്നും നമ്മൾ എന്ത് യൂസ് ചെയ്യുന്നില്ല, ഒരിക്കലും ഡെറിവേറ്റീവ് യൂസ് ചെയ്യുന്നില്ല. വിത്തൗട്ട് യൂസിങ് ഡെറിവേറ്റീവ്സ് ആണ് ഇൻക്രീസിങ് ഡിക്രീസിങ് നമ്മൾ ചെക്ക് ചെയ്യുന്നത്. x1 x2നേക്കാൾ കുറവാണെങ്കിൽ a ഒരു പോസിറ്റീവ് നമ്പർ ആൻഡ് ഇറ്റ് ഈസ് ഗ്രേറ്റർ ദാൻ 1. greater than 1 ആകുമ്പോൾ 2, ഇപ്പോൾ ഇത് 2ഉം 3ഉം ആണെങ്കിൽ 2 is less than 3, then we know that if it is 5 ആണ് a എങ്കിൽ 5 square is less than 5 cube, 7 square is less than 7 cube. അപ്പോൾ ഇൻഇക്വാലിറ്റിയിൽ ചേഞ്ച് വരില്ല. ഗ്രേറ്റർ ദാൻ 1 ആണെങ്കിൽ. if it is less than 1 and greater than 0, 0 ൻ്റെയും 1 ൻ്റെയും ഇടയിലാണെങ്കിൽ ഇൻഇക്വാലിറ്റി സൈൻ എന്താവും? റിവേഴ്സ് ആവും. എന്ന് വെച്ചാൽ 1/5 സ്ക്വയർ ഈസ് ഗ്രേറ്റർ ദാൻ 1/5 ക്യൂബ്. നമുക്കറിയാം ഡിനോമിനേറ്റർ കൂടുമ്പോൾ വാല്യൂ കുറയുന്നുള്ളത്. അപ്പോൾ ഇവിടെ എ എന്ന് പറയുന്നത് 5 ആവുമ്പോൾ നമുക്ക് inequality reverse ചെയ്തില്ല. but if a is equal to 1/5, then the sign of inequality get reversed. since a എന്ന് പറയുന്നത് ഇവിടെയാണെങ്കിൽ a is greater than 1, ഈ കേസിലാവുമ്പോൾ 0 less than a less than 1. അപ്പോൾ അടുത്ത കേസ് നമ്മൾ ഇങ്ങനെ ഒരു പ്രോബ്ലം എടുക്കുകയാണെങ്കിൽ ഇവിടെ ഇൻഇക്വാലിറ്റി റിവേഴ്സ് ചെയ്യും. ഇതിൽ കുഴപ്പമില്ല. a raised to x1 is less than a raised to x2 തന്നെ വരും. that means f of x1 is less than f of x2. thus we get x1 less than x2 implies f of x1 is less than f of x2. f of x is a strictly increasing function. Next problem, question number 4. Show that the function f of x is equal to a raised to x, and let a raised to x 0 less than a is less than 1, that is a lies in between 0 and 1 and x is an element of capital R, is strictly decreasing in capital R. Now the given function is f of x is equal to a power x, and given that a is any number in between 0 and 1 and in x is an element of R. Now let take x1 x2 element of its domain. Now as usual we start with x1 less than x2. that implies we know that a raised to x1 is greater than a raised to x2. since a is less than 1 and it is greater than 0, that implies we get f of x1 is greater than f of x2. x1 less than x2, we get f of x1 greater than f of x2. We say that f of x is a strictly decreasing function. Question number 5. Show that f of x is equal to ax plus b, a greater than 0 and x is an element of R, is a strictly increasing function. We use the same procedure. f of x is equal to ax plus b, and given that a is greater than 0. Now let us take two elements, x1 x2 element of capital R, such that x1 is less than x2. that implies if we multiply by a, since a is greater than 0, that is it is positive, then the sign of inequality will not reverse. If it is less than 0, then sign of inequality will get reversed. Then we add b on both sides. We get f of x1 is less than f of x2. Thus when x1 less than x2, we get f of x1 less than f of x2. Then we say that the function is strictly increasing on its domain, capital R. Okay. Next module namukku using derivatives we find the intervals where the function is increasing or decreasing. Next module namukku cheyam. Okay. Thank you all.